Algebra 1's Lesson 5.08, Growth and Decay Equations. So welcome to Algebra 1. This is for November 1st, 2018. So here are the standards and learning targets. So I can solve problems by writing and solving exponential equations in one variable is our goal. So for growth and decay functions, you can model growth or decay by a constant percent increase or percent decrease with these formulas. This part right here represents the final amount. B is my initial or starting amount, and then I do 1. If it's a growth, I'm going to do the plus. R is my rate, and T is my time. Notice if it's decay, I put the minus there. This arrow should also be going more towards the R. There we go. So let's look at question number 1 on your ticket out the door 5.08. So I am going to go through the ticket out the door as I'm doing this mini lesson. So make sure you have that ticket out the door open. So question 1, a population of insects grows exponentially as shown in the table. Suppose the increase in population continues at the same rate. What is the insect population at the end of week 11? So instead of writing out all of my numbers to 11, I'm going to use my equations. So I'm first asking myself, is this a growth or decay? This is a growth. It says it's growing. So that means I use my growth formula. The one with the plus sign is my growth formula. And these formulas are given to you on the end of course test, so you don't have to memorize them. So what is your starting amount? So how many am I going to begin with? So I am starting this with 20 insects. That is my beginning amount. My rate. So how much am I going up by? And this is a little bit trickier. Okay, so my rate here is I'm going to divide this. So 30 divided by 20. And I get 1.5. And I'm going to do that again, and I should get the same number. So 45 divided by 30, I also get 1.5. This one kind of goes a little bit outside of the realm with the formula. It's basically this whole part right here. So this is going to be 1.5. My rate is it's increasing by 50%, so 0.5. Kind of ignore this part for now. This one's just a little bit different than the other ones. The time, it's going until week 11, so 11 is going to be my time. So I start with 20, and then I have 1.5 in there as my rate to the 11. So kind of, like I said, just ignore this part right here for now. We're just using this where we divided, 30 divided by 20. And then we type this into the calculator. So let me grab up Desmos and show you what this looks like. So if I'm in Desmos, I have 20 times 1.5. Make sure you put the parentheses. And then I'm going to put the exponent. I hit this A to the B button, and it gets me my exponent, and I hit 11. So notice I get 1,729.95. I am going to take this answer, and I'm going to round up because I'm talking about bugs. So that's 1,730 insects, and that is my answer. For question number 2 on Ticket Out the Door 5.08, we're talking about half-life. Half-life, if we look down here, means that it loses 50% after the amount of time. So R is negative 0.50. To determine T, calculate how many halves occur in the time frame. And it always gets a little confusing because these are talking about elements, and this is what they use to actually find the life of like dinosaur bones or carbon dating. That's what they're using as half-life. So it's confusing because it says cobalt 60. Ignore the 60. It's nothing to do with this problem. It's an extra number. This is the whole name of the item. So it's not going to be a part of the problem. So cobalt 60 has a half-life of about 5 years. How many grams of a 300-gram sample will remain after 20 years? Well, this is a decay problem. It is getting smaller. Your starting value here is 300. That's how many grams we started with. Our rate is that negative 0.5. It already gave it to us as a decimal. It was 50%. And remember, this is a decay, so we're already using that minus sign. The time. Now, to figure out the time, I got to figure out my half-life. So this is where it's a little different. I take the 20 years, and I'm going to figure out how many half-lives, how many 5-year periods are in that. So I'm going to divide it by 5. 20 divided by 5 is 4. So there are 4 half-lives in there. So this is my formula. 300 times 1 minus 0.5 to the 4. And we type that into the calculator. So I'm going to grab my Desmos calculator again. So I type in 300 and then 1 minus 0.5. And then this A to the B button is going to get me my exponent. And I'm going to put a 4 up there. So my answer is 18.75. So I rewrite that over here, and I see that answer is C. So after 20 years, there's going to be 18.75 grams left. So here's the next one. This is my compound interest formula. So this formula will be given to you on the EOC as well. So notice the breakdown. Basically, you have to memorize how this formula is being broken down. You're going to you won't have the explanation of each part. So A is the final amount. P is your initial principal, so your initial amount. R is your rate. N is how many times we're compounding this per year, and that goes in these 2 spots. And then T is my number of years. So we use this a lot in financing and in loans. So after 8 years, what is the total amount? So here's some information here. I'm going to just start highlighting. Of compound interest investment of $25,000 at 3% interest compounded quarterly. So let's label all of these. So I need my initial, I need my rate, I need my compounded amount, and my time. Well, I see the time is 8. The initial amount of money that I have is $25,000. My rate is 3%. If you struggle with moving that decimal over, to get the decimal, do 3 divided by 100. And I get 0.03. And N, compounded quarterly. How many times a year is quarterly? There are 4 quarters in a year. So now I'm going to take all of this information and plug it into my formula. So it's a lot of knowing where to put stuff in. So I put the 25,000 first. That's my P. 1 plus, I'm going to put my rate over 4 because that's how many times it's compounded. 4 times 8 is in the exponent. So now I'm going to take this into Desmos and type this in. So as you can see, I already typed it in, but I'm going to type it in one more time to show you. So $25,000, parentheses 1 plus, I hit the A over B button for my fraction, so 0.03 over 4. Close the parentheses, and now I'm going to do my exponents. 8 times 4, and I get my answer. $31,752.78. That's how much I'm going to have in interest from my investment. So this has a lot to do with loans, and like how your mortgage or your car payments are accumulating interest. It's really important to know these rules because you might not realize how much interest you're going to end up paying. So knowing this formula will help you out later when you need to take out loans or use credit cards. So this is a good formula to know. Question number 4. The bird population on an island is declining at a rate of 2.2% per year. The population was 3,500 in 2009. Which answer is the best prediction of the population in 2014? So this is declining. It's a decay problem. So that's this formula. Notice it doesn't say anything about compound interest or interest at all, so that's how I know it's this formula. My starting amount of birds is 3,500. That's where we're beginning. Our rate is 2.2%. As a decimal, I just divide that by 100. And I get 0.022. The timeline, this is a little tricky. On the time, I take the 2009 and 2014, and I just subtract them to figure out how many years have passed. So 5 years. So my function here is 3,500 times 1 minus my rate to the 5th power. So now I'm going to take this and go into Desmos. So for this function, I do 3,500, parentheses 1 minus 0.022, close my parentheses, and I hit the A to the B button to get the exponent. And I'm going to type in 5, and I get my answer. And I'm going to round this because I can't have part of a bird. So that answer, it was originally this, but I'm just going to round up. And that's going to be 3,132. So it has declined, the bird population. And now it's at 3,132. So this week, today, you have the ticket out the door to do. Tomorrow, you're going to have your Unit 5 test. There will be recordings coming out with that as well. So look out for those. Make sure you're using your resources in the OHS over these units. And as always, email me if you have questions.